If the quantum theorists are correct, we will never understand the fundamental level of the universe. Our hopes of finding an ultimate theory will fail, and the human race will hit a roadblock it can't break through. But what if they're wrong? What if the truth about what happens deep inside you, me, and everything else in the universe is there, if we're willing to look for it? For most of the 20th century, scientists believed quantum physics could not be explained, that we would just have to accept that we'll never know why things behave as they do down at the deepest levels of existence. But now, a growing band of rebel scientists thinks there may be a logical explanation for quantum weirdness after all, and new hope for revealing the ultimate truth of our universe. The trail begins here, with a drop of silicon. In his Paris laboratory, physicist Yves Coudet and his team conduct an amazing series of experiments. They are observing the behavior of silicon droplets bouncing in lockstep on a vibrating plate.
The liquid of the drop never touches the liquid of the substrate, so they're always separated by air film. And in fact, this is stable. You can keep the drop bouncing on the liquid surface for several days if you wish.
Using a camera that shoots 1,000 frames per second, Coudet has discovered that these droplets mimic behavior seen in the quantum world. And that shouldn't be possible, because the quantum world and the large-scale world play by two different sets of rules. Yet here we see a single droplet moving randomly like a quantum particle, but behaving like a quantum wave. If you watch this carefully, you'll notice that the wave appears to be guiding the droplet. In fact, the wave fields around the droplets develop a memory of the trails they have followed. Despite their random behavior, they follow a small number of paths. Again, this is eerily similar to the behavior of quantum objects. This runs so contrary to popular belief that at first, Coudet refused to believe what he was seeing.
In any physics experiments, you only see what you are prepared to see. Of course, this was very obvious that there was a memory, but it took us some time to realize that it was that we were observing, because you have to adapt to this new idea.
Perhaps most revealing of all, Coudet has reproduced the double-slit experiment using his bouncing silicon droplets. The mystery of quantum mechanics is, how can things like electrons sometimes behave like particles and sometimes behave like waves? Perhaps this is the answer. They are particles and waves. Of course, this system, though small, is not quantum.
Our system is not a model of quantum mechanics, but it is an association of a particle and a wave, and some of its properties are similar to the properties that are observed in quantum mechanics.
Coudet won't claim that his experiments show us what is really happening down at the deepest layers of existence.